When it comes to power series, if A is the center of the series, then you have the summation of C sub n times x minus a to power n, and start from 0 goes to infinity. We can write this in expanded form. When n is equal to 0, the very first term is c sub 0, x minus a to power 0. When n is equal to 1, you get the second term, which is c sub 1, x minus a to power 1. When n is equal to 2, you end up with c sub 2, x minus a to power 2 plus the rest of the terms. In simplified version, you have c sub 0 plus c sub 1, x minus a plus c sub 2, x minus a to the second power plus the rest of the terms. If a is equal to 0, if the center is 0, then the power series can be written as the summation of Cn x to power n, and start from 0 to infinity with the same process. You see you have c sub 0 plus c sub 1x plus c sub 2x squared plus the rest of the terms. This series behaves the same as the series that you saw before. To check the convergence and divergence of the series, we're going to use ratio test. Convergence slash divergence of a power series, we use ratio test. Well, remind yourselves of ratio test. In the ratio test, if we have a series summation of an and start from 1 goes to infinity, you start taking the limit of the absolute value of an plus 1 divided by an as n goes to infinity. This ends up with limit L. If L is less than 1, then we say that the series is convergent. So we're going to use the ratio test and check the convergence and divergence of the power series. So here you have your power series. Power series, for example, the summation of Cn x to power n and start from 0 to infinity, the general term is nothing but Cn x to power n. So an is Cn x to power n. An plus 1 is Cn plus 1 x to power n plus 1. So what's happening here? We are taking the limit of the absolute value of an plus 1 divided by an as n goes to infinity, or basically you're finding the limit of the absolute value of Cn plus 1 x to power n plus 1 divided by Cn x to power n as n goes to infinity. This guy must be less than 1, so we get a convergent power series. You can simplify this as well. This limit can be written as the limit of absolute value of Cn plus 1 x to power n times x divided by Cn x to power n as n goes to infinity. You can cancel out x to the n on the numerator and the denominator. And this limit becomes the limit of the absolute value of Cn plus 1 times x divided by Cn as n goes to infinity. And this quantity must be less than 1. Let's take a look at a couple of examples. In this example, I ask you to check the convergence for the following series. Check the convergence of the power series, which is the summation of n factorial x to the n, and starts from 0, goes to infinity. First of all, please pay attention. This is indeed a power series. A power series centered at the origin is denoted by the summation of Cn x to power n, and starts from 0, goes to infinity. So if you compare these two, your Cn in this case is equal to n factorial. Perfect. So by ratio test, we're going to check the convergence and divergence of this power series. Ratio test help us to analyze the convergence and divergence of this power series. So you take the general term, find the limit of an plus 1 divided by an as n goes to infinity, and this guy must be equals to less than, your L must be less than 1. So you have absolutely convergence, or basically the convergence in this case. Perfect. So let us do a little bit of algebra, then do the calculus. We are finding the limit of an. This is your general term. So you have to take everything. By ratio test, we are finding the limit of the absolute value of n plus 1 factorial x to power n plus 1 divided by n factorial x to power n as n goes to infinity. Again, on your numerator, you have an plus 1. So wherever you see n, you're going to use n plus 1. On the denominator, you copy down the general term as you see fit. Now let us do a little bit of algebra and simplify this as much as we can. For example, n plus 1 factorial is n plus 1 times n factorial. X to power n plus 1 can be written as x to the n times x. So this limit becomes the limit of the absolute value of n plus 1 times n factorial x to the n times x divided by n factorial times x to the n. We are taking this limit as n goes to infinity. Let's get rid of x to the n and x to the n. Also, you can cancel out n factorial and n factorial. So we're left with the limit of the absolute value of n plus 1 times x divided by 1. So you can simplify this. You end up with the limit of absolute value of n plus 1 times x as n goes to infinity. So we want this to be less than 1. How is this possible? if you take this limit when n goes to infinity, this is going to be diverging to infinity unless x is equal to 0. So let us check this analysis. The limit of absolute value of n plus 1 as n goes to infinity goes to infinity. There is no doubt there. Unless x is equal to 0. If x is equal to 0, you have the limit of n plus 1 times 0, which is equal to 0. So this guy is going to be convergent only if x is equal to 0. And it's going to be divergent only if your x is non-zero. So the series is convergent when x is equal to 0. Let's take a look at the series. Our series is equal to the summation of n factorial x to the n starts from 0, goes to infinity. If you write this guy in expanded form, you get 0 factorial x to power 0 plus 1 factorial x to power 1 plus 2 factorial x squared plus 3 factorial x to the third, and you continue this process. So 0 factorial, as you remember, is equal to 1. X to 0 is also 1. So you end up with 1 factorial times x, which is x, plus 2 factorial x squared, plus 3 factorial x cubed, plus the rest of the terms. Or basically, you have the summation of 1 plus x plus 2x squared plus 6x cubed plus the rest of the terms. This sum converges only if x is equal to 0. This sum is a convergent sum only if x is equal to 0. For any other value of x, you get a divergent series. Any other value of x, we get a divergent series. So that's how you analyze a power series in general. Here you have the summation of n factorial x to the n start from 0 goes to infinity. For a power series centered at the origin, we have the following definition. The summation of Cn x to power n start from 0 goes to infinity. In this example, Cn is equal to n factorial, but when we're applying the ratio test, hey, you have the limit of the absolute value of an plus 1 divided by an as n goes to infinity to be convergent. For the series to be convergent, this limit must be less than 1. So when you take the limit, on the numerator you have an plus 1, on the denominator you have an. Wherever you see n, you're going to substitute that by n plus 1, and we took the limit must be less than 1, but since you have the limit of absolute value of n plus 1 as n goes to infinity, it always goes to infinity. You only choice have x be equal to 0. So this series is convergent only if x is equal to 0. We can write the series in expanded form as well and analyze the behavior of the series, which is 1 plus x plus 2x squared plus 6x cubed and so on.